Hi, welcome back. We're going to pick up straight from where we left off in the last video and check out the manipulating the document object from console section in the part 0B of the full stack open curriculum. Okay, so the topmost node of the DOM tree of an HTML document is called the document object. So this is the initial root object name, as you can see in the dev console. Actually, I'll just open that up again. Give me one sec. Okay, here we go. Let's go back to the section. And so in the Notes app, we can just type document in the console and get that object there. There we go. So this is the DOM tree that was discussed in the previous video. Let's add a new note to the page from the console. First, we'll get the list of nodes from the page, the list in the first URL element of the page. Okay, so I think we need to create an. I'm not actually sure why they're not declaring using a const or let here. We'll just copy this code and see how run it in the console, see what it does. Please type allow listing. Okay. Okay, so here we've uh, gotten the URL element by with this command document.get elements by tag name, and then getting all the available URL tags and getting the first one out of the array and then assigning it to the variable list. So here's the unordered list highlighted up top. And then create a new element and add some text content to it. So we'll just copy this part. If this is new to you, I'd recommend typing it out so it's a bit easier to learn the code rather than copying it. For the demonstration here, I'm just gonna copy and paste the code as it's a bit quicker. Okay, so here we've created a new list element and then assigned this string to that element that's assigned to the variable new element. And add the new li element to the list. So this is where it should show on the page once we enter this command. I'm guessing it's at the bottom, so let's see here. Yeah, it should appear below this one here. There we go. So page manipulation from console is easy. Yep, and that matches the string here. Even though the page updates on your browser, the changes are not permanent. If the page is reloaded, the new node will disappear. Because the changes were not pushed to the server, the JavaScript code the browser fetches will always create the list of nodes based on JSON data from the address. This is the data here. So every time the page reloads, it only pulls from this data.json. And since we're only working in the browser level, it's only temporary. This is only saved temporarily in memory in the browser. So once we reload, it's pulling from the backend, and since we haven't dealt with it on the server side, it'll just disappear. So if we refresh, that list item is now gone. CSS, the head element of the HTML code of the nodes page contains a link tag which determines the browser must fetch a CSS style sheet from the address main.css. So if we go back to the network tab, here is the main.css. It's quite minimal at the moment. As you can see, there's only 8 lines of code. Uh, yeah, so if we look at the response here, this is the line of code that the information here is referring to. It's the style sheet, and it's located on this URL here. So this is what's called a relative URL. Basically, it's relative to the absolute URL that is uh, that is this one here. So if we copy this and replace it here, we should be able to see the same file. One sec. We should be able to see the same file as the CSS information that is here. So if I press enter, we just wait for it to load. See, this is the same CSS code as we saw before. Okay, so the fetch CSS file looks like as follows. It's the same one that I just showed you, and the file defines two class selectors. These are used to select certain parts of the page and to define styling rules to style them. A class selector definition always starts with a period and contains the name of the class. So the period is the dot here, and it can be assigned to multiple HTML and elements. Classes are attributes which can be added to HTML elements. CSS attributes can be examined on the Elements tab of the console. So if we go to, here is the container. If we go into the Elements tag, we see that this div class has the same class container. And then here we can see what styles are assigned to that class. So we have the padding, which is highlighted in green, and the border, which is the black border you see. So quite minimal. For example, if I untick this, you'll see that the border disappear. Yes, that black border has now disappeared. And same with the padding, like so. Mm, okay, so that is the Elements tab of the console. The outer div element has the class container, as I mentioned before, and the URL element contains the list of nodes, has the class nodes. The CSS rule defines that elements with the container class will be outlined with 1 pixel wide border. It also sets 10 pixel padding on the element. This adds some empty space between the element's content and the border. So this is all the information that's listed here. The second CSS rule sets the text color of the nodes class as blue. The HTML element can also have other attributes apart from classes. The div element containing the nodes has an ID attribute. JavaScript code uses the ID to find the element. So this means that the JavaScript code is using most likely document.getElement by ID, which is trying to find this ID attribute. The Elements tab of the console can be used to change the styles of the elements. Okay, which means that we can, similar to how we use the console to add a note temporarily, we can also use this to change the styling. Um, so for example, if I were to increase the pixel size, as you can see, the border is dynamically being um, getting thicker as I increase the pixels. Similar with the padding, I can increase the padding like so, or decrease the padding. But again, just like the console, um, it's only temporary. So if I refresh the page, it goes back to as before. Yes, so changes made on the console will not be permanent. It will, if you want to make lasting changes, they must be saved to the CSS style sheet on the server. Okay. Loading a page containing JavaScript review. Let's review what's happening when this page here is open on the browser. So again, this is the, I think from memory it was called the sequence diagram um, from last video. As you can see, this one's a bit more complicated than the previous one. So uh, time starts from the top going down to the bottom. So the first thing that gets passed is the HTML. element as denoted here. Links in the HTML code cause the browser to also fetch the CSS style sheet main.css and the JavaScript code file main.js. So this is the main.css request, which then gets fetched back, then gets sent back, and also the main.js JavaScript file. So the browser then executes the JavaScript code. The code makes an HTTP GET request to the address, uh, and then which returns the node as JSON data. So as the JavaScript code gets executed, it also makes a request for data.json file, and then that's when the content, the JSON object comes back, and the browser then executes the function that renders the nodes, which is these lists here. Okay, so when the data has been fetched, the browser executes an event handler, which renders the nodes to the pages using the DOM API. Forms and HTTP post. Next, let's examine how adding a new node is done. The nodes page contains a form element. Okay, so this is this part here, which is just a normal simple text input and a save button. So if we go to the elements page, that is here. So that's the save button and that's the input field. When the button on the form is clicked, the browser will send the user input to the server. Let's open the network tag to see what submitting the form looks like. So we'll just go here and then make a node, node 1, let's say, and then we'll do save. Here it's making most likely a post request called a new node. We'll just quickly look at the yes, so node 1 has been added successfully. Yes, it's a post request. As you can see, if you remember from the previous video, all of the previous requests were get requests. This one is a post one because we're changing the database. We're adding to the database in the backend. And the response header is showing that it's still HTML that's being sent back. So surprisingly, the submitting the form causes no fewer than 5 HTTP requests. The first one is the form submit event. Let's zoom into it. Yeah, so this is the one that I showed here. It is an HTTP post request to the server address new node. The server responds with HTTP request status code 302. This is a URL redirect with which which the server asks the browser to do a new HTTP GET request to the address defined in the header's location, the address nodes. In other words, .302 is causing the server to redirect to this URL here. So the browser reloads the nodes page. The reload causes 3 more HTTP requests, fetching the style similar as before to the main.js and the raw data of the JSON file. It's a little bit confusing because even though it's a redirect status code, we're actually loading the same page. So it's almost like it's a redirect, but it's redirecting to the same place. So that's why it's a reload. The network tab also shows the data submitted with the form. On newer Chrome, the form data dropdown is within the new payload tab, located to the right of the headers tab. Okay, the form tab dropdown with the new payload tab located in the right of the headers tab. Okay, so that must be down here. Oh, it's in the payload here. So that's the form data, and that's the text of the node, which matches the one I added here. The form tag has attributes action and method, which defines that submitting the form is done as an HTTP post request to the address new node. Yep, so this is here with the method post. That's how it's knowing that it has to send a post request as opposed to a get request. The code on the server is responsible for the post request is quite simple. Note, this code is on the server and not the JavaScript code fetched by the browser. So we don't, from the browser here, we can't actually get access to that code because it's in the server. So this is the express controller that deals with what happens when a post request gets sent to this URL. And so, in other words, what's happening is a new node is being pushed with the new date to denote when this occurred, and the rec.body.node is just whatever that's typed in to this input field here. Data is sent as the body of the post request. The server can access the data by accessing the rec.body field of the request object rec. The server creates a new node object and adds it to an array called nodes. So nodes is what's saved. Sorry, nodes is what's the variable that is holding the list of nodes that are displayed here. And each node has two fields, content containing the actual content of the node and date containing the date of the time of the node is created. The server does not save new nodes to a database, so new nodes disappear when the server is restarted. Oh, okay. So I don't think it's yeah, just like I don't think it's an actual database. It might just be an array of objects in the server code. And so whenever the server is restarted, because the array of objects is in memory in the server, every time it restarts, it'll just be reset. So Ajax, the nodes, okay, next section, Ajax. The nodes page of the application follows an early 90s style of web development that uses Ajax. As such, it's on the crest of a wave of early 2000s web technology. Ajax, which stands for Asynchronous JavaScript and XML, is a term introduced in February 2005 on the back of advancements in browser technology to describe a new revolutionary approach that enabled the fetching of content to web pages using JavaScript included within the HTML without the need to re-render the page. Before the Ajax era, all web pages worked like the traditional web applications we saw earlier in this chapter. All of the data shown on the page was fetched with the HTML code generated by the server. The nodes page using Ajax to fetch the nodes data. Submitting the form still uses the traditional mechanism of submitting web forms. So you will find that as we go through the course, um, this is essentially, even though it was revolutionary at the time in 2005, we'll be doing things a little bit differently using the fetch API and promises. So the application URLs reflect the old carefree times. JSON data is fetched from the URL, and new nodes are sent to the URL to this page here. Nowadays, URLs like these will not be considered acceptable, as they don't follow the acknowledged conventions of RESTful APIs, which we will look into more in part 3. The thing termed Ajax is now so commonplace that it's taken for granted. The term has faded into oblivion, and the new generation has not even heard of it. Okay, so yes. Now let's move on to single page app, which is more the modern way of doing things. So in our example app, the homepage works like a traditional web page. All of the logic is on the server, and the browser only renders the HTML as instructed. The notes page gives some of the responsibility generating the HTML code for existing notes to the browser. The browser tackles this task by executing the JavaScript code it fetches from the server, and the code fetches the nodes from the server as JSON data and adds HTML elements for displaying the nodes to the page using the DOM API. So it's just reiterating what's already been explained in the previous few sections. This is again, like I mentioned here, a traditional way of doing web pages. So in recent years, the single page application, spa style of creating web applications has emerged. Spa style websites don't fetch all of their pages separately from the server like our sample application does, but instead comprise only of one HTML page fetched from the server, the contents of which are manipulated with JavaScript that executes in the browser. In other words, just like how we saw that um, there was a 302 post request that reloaded the page, the whole page, when something added was new, when something new was added. With a single page application, that isn't required. So the notes page of our application bears some resemblance to spa style apps, but it's not quite there yet. Even though the logic for rendering the notes is run on the browser, the page still uses the traditional way of adding new notes. The data is sent to the server via the form submit, and the server instructs the browser to reload the page with a redirect. Yes, like I mentioned just before. So single page application versions of our example application can be found at this URL here. At first glance, the application looks exactly the same as the previous one. The code is almost identical, but the JavaScript file is different, spa.js, and there's a small change in how the form tag is defined. Yes, so you should notice here in the spa example that um, the main difference here is that there's no method attribute in the form HTML tag. So here we've got the traditional one, and again, see, there's the action and then the method equals post. Um, in the spa version, it's just an ID. There's no action and there's no method. That's handled purely with the spa.js HTML JavaScript file. Sorry, not the HTML file, the JavaScript file. The form has no action or method attributes to define how and where to send the input data. Yes, so open the network tab and empty it. When you now create a new node, you'll notice that the browser sends only one request to the server as opposed to 5 in the previous example. So we now it's empty and then we add a new node. So we do node 2. Actually, instead of doing node 2, we do node spa instead to differentiate. See, it's uh, one request. It's a post request with the statics code this time of 201. So there was no reload that occurred. The post request to address new node spa contains the new node as JSON data containing both the content of the node and the timestamp date. So that's the same as before. The payload is the same. The content type header of the request tells the server that the included data is represented in JSON format. We can see that here. So instead of being text/HTML, like here, in the SPA version, it's application/JSON. So what's being sent back is JSON. Without this header, the server will not know how to correctly pass the data. The server, oh, sorry, that's the request header there. Yep. So the server responds with status code 201 created. This time, the server does not ask for a redirect. The browser stays on the same page and it sends no further HTTP requests. The SPA version of the app does not traditionally send the form data, but instead it uses the JavaScript code it fetches from the server. We'll look into this code a bit, even though understanding all the details is not important just yet. So this is the SPA version of the JavaScript code, which we can find here. Mm, yeah, as you can see, it's a bit different from, oh, sorry, this is the SPA version, and it's a bit different from the main.js one in the traditional example. So let's go through the code. The command document.getElementById by ID nodes form instructs the code to fetch the form element from the page and to register an event handler to handle the form's submit event. So this gets the HTML element with the ID notes underscore form, and then this part here is what happens when the user clicks on the submit, not the submit button, but the save button here. So this event handler handles what happens when the user clicks save, basically. The event handler immediately calls the method e.preventDefault to prevent the default handling of the form submit. The default method would send the data to the server and cause a new GET request, which we don't want to happen. So in other words, we're manually disabling what the default behavior is, which is um, if there's no post request, post element here, by default, it'll just send a GET request, and we're just disabling that from happening with our SPA example, as we're doing it the more modern way of um, sending data through the form submission. Then the event handler creates a new node, adds it to the nodes list with command nodes.push underscore, brackets node, re-renders the node list on the page and sends the new node to the server. The code for sending the node to the server is as follows. So we have this. The code determines that the data is to be sent with an HTTP post request, and the data type is to be JSON. The data type is determined with content type header, and then the data is sent as JSON string. So this is where we're explicitly setting that the request header has to be an application/JSON, which is reflected, if you remember, which is reflected here. The application code is available at the GitHub example. It's worth remembering that the application is only meant to demonstrate the concepts of the course. The code follows a poor style of development in some measures and should not be used as an example when creating your applications. The same is true for the URL used. The URL new_node_SPA that new nodes are sent to does not adhere to the current best practices. So it doesn't really have a lot of security measures in mind. It's just a very bare bones example of what a single page application would look like. JavaScript libraries. The sample code is done with so-called vanilla JavaScript using only the DOM API and the JavaScript to manipulate the structure of the pages. Instead of using JavaScript and the DOM API, different libraries containing tools that are easier to work with compared to the DOM API are often used to manipulate pages. One of these is the ever so popular jQuery. jQuery was developed back when web applications mainly followed the traditional style of the server generating HTML pages, the functionality of which was enhanced on the browser side using JavaScript written with jQuery. One of the reasons for the success of jQuery was its so-called cross-browser compatibility. The library worked regardless of the browser or the company that made it, so there was no need for browser-specific solutions. Nowadays, using jQuery is not as justified given the advancement of JavaScript and the most popular browsers generating supporting basic functionalities well. Yes, so jQuery in some ways solved a problem in a lot of ways that are not as problematic as before back in the 2000s. So as this text mentions, jQuery is not as justified as before. So the rise of single-page applications brought several more modern ways of web development. than jQuery. The favorite of the first wave of developers was Backbone.js. After its launch in 2012, Google's AngularJS quickly became almost the de facto standard of modern web development. However, the popularity of Angular plummeted in October 2014 after the Angular team announced the support for version 1 will end, and that Angular 2 will not be backwards compatible with the first version. Angular 2 and the newer versions have not gotten too warm of a welcome. Currently, the most popular tool for implementing the browser-side logic of web applications is Facebook's React library. During this course, we will get familiar with React and the Redux library, which are frequently used together. The status of React seems strong, but the world of JavaScript is ever changing. For example, recently a newcomer Vue.js has been capturing some interest. Vue is quite popular, um, and also Svelte is gaining steam as well. So for a current version of um, what the landscape of JavaScript is like, you can check out State of JavaScript, which is quite a good resource based off a survey that's done, that's asked to many um, developers, professional developers. I wonder, so right now there's State of 2003. So the results haven't been tallied, I don't think. We can look at the 2022 for now and view the results. So under libraries, as mentioned before, we can see that the tier list right now is React having um, an A grade. Where is Vue? So Vue has a B grade, and Angular, as we have seen, is very low at the bottom and the C grade. So this is quite similar to what's been described in the section of how things are happening, how things are going right now. You might be looking at this at a later date, but if you want a relatively current view of what's happening, check out the State of JavaScript website. Full stack web development. What does the name of the course Full Stack Web Development mean? Full stack is a buzzword that everyone talks about, but no one knows what it means, or at least there's no agreed upon definition for the term. Practically all web applications have at least two layers. The browser, being closest to the end user, is the top layer, and the server is the bottom one. There is often also a database layer below the server. We can therefore think of the architecture of a web application as a stack of layers. Often we also talk about the front end and the back end. The browser is the front end, and the JavaScript that runs on the browser is the front end code. The server, on the other hand, is the back end. In the context of this course, full stack web development means that we focus on all parts of the application, the front end, the back end, and the database. Sometimes the software on the server and its operating system are seen as parts of the stack, but we won't go into those. We will code the backend with JavaScript using Node.js runtime environment. Using the same programming language on multiple layers of the stack gives full stack web development a whole new dimension. However, it's not a requirement of full stack web development to use the same programming language, JavaScript, for all layers of the stack. So there was a brief mention in this course of other alternatives with different languages. For example, Python using the Django framework, or Ruby with the Ruby on Rails framework. So there are many other um, alternatives other than Node.js or with JavaScript. It used to be more common for developers to specialize in one layer of the stack, for example, the backend. Technologies on the backend and the front end were quite different. With the full stack trend, it's become more common for developers to be proficient in all layers of the application and the database. Oftentimes, full stack developers must also have enough configuration and administration skills to operate their applications, for example, in the cloud. So that has more to do with AWS and Azure, and Google, yeah, Google as well. So JavaScript fatigue. Full stack web development is challenging in many ways. Things are happening in many places at once, and debugging is quite a bit harder than with regular desktop applications. JavaScript does not always work as you'd expect it to compared to many other languages, and the asynchronous way its runtime environments work causes all sorts of challenges. Communicating on the web requires knowledge of the HTTP protocol. One must also handle databases and server administration and configuration. It would also be good to know enough CSS to make applications at least somewhat presentable. The world of JavaScript develops fast, which brings its own set of challenges. Tools, libraries, and the language itself are under constant development. Some are starting to get tired of the constant change and have coined a term for it: JavaScript fatigue. See these list of these links of articles as examples. You will suffer from JavaScript fatigue yourself during this course. Fortunately for us, there are a few ways to smooth the learning curve, and we can start with coding instead of configuration. We can't avoid configuration completely, but we can merely push ahead in the next few weeks while avoiding the worst of configuration hells. Okay, so that concludes the this section, part 0B. This is all the learning materials that you will need for to review. In the next video, we'll start on working on these 6 exercises, part 0.1 to 0.6. Thank you for watching. See you in the next video.